So when we're talking about converting moles to grams or grams to moles, you're going to have one basic conversion factor. And if you'll remember, conversion factors are always going to be equal to 1 because your numerator and your denominator are equal to each other. So at the top of page 133, figure 37 shows this. A lot of students have had trouble with it, so I'm just going to write it a little differently here in your notes. If you're given moles, units of moles, an amount, your conversion factor is going to be the molar mass over 1 mole. Now with this being on the bottom, your units, moles and moles, would cancel each other out, and you'd just be left with grams of whatever substance. If you're given grams, so if you're given the mass of a substance, you're going to multiply by the conversion factor 1 mole over the molar mass. And of course, the molar mass is equal to the mass number. So that's the number found on the periodic table, the big one, the number of protons and neutrons. So for example, in 1 mole of neon, if we look at the periodic table at the noble gases on the far right, in 1 mole of neon, you have 20.179 grams of neon. So from page 133, we have 4 example problems. The first one, you're converting 2.5 moles of sulfur into grams of sulfur. So to do that, you're going to need to create a conversion factor. And if you'll remember from our work with conversions earlier, a conversion factor is just multiplying by 1. And when you multiply by 1, you're not changing the identity of the number, you're just doing a conversion. So we need to find the relationship between 1 mole of sulfur and its mass in grams and multiply that by 2.5 moles of sulfur. So we want the unit of moles to cancel out. So 1 mole of sulfur goes on the bottom. And we can reference the periodic table of elements. The mass number for sulfur is 32.06. So 32.06 grams of sulfur. Again, the mass number tells you the mass of 1 mole of an element. So 1 mole of sulfur and moles of sulfur cancel each other out. We're left only with the unit grams of sulfur. You multiply 2.5 by 32.06. So when you multiply 2.5 by 32.06, that's going to give you 80.15. We'll round that off to 80.2. And we want to include our units, grams of sulfur. The next problem, 1.8 moles of calcium. 1.8 moles of calcium. Again, you've got to create your conversion factor here. Since you are given units of moles, 1 mole goes on the bottom. So in these conversion factors, 1 mole is either going to be on the bottom or on the top. If you're converting 2 moles, it goes on the top. If you're converting to grams, moles goes on the bottom. So you need to look at the periodic table. Look for calcium's mass number. It's an alkaline earth metal, so it's going to be in that second column. It's 40.08. And that would be grams of calcium. So in 1 mole of calcium, there are 40.08 grams. Okay, so 1.8 1.80 times 40.08. 1.80 times 40.08. That's going to give you 72.144. We'll just round that off to 72.1 and include our units, grams of calcium. Now, let's go down here and do our next two example problems. Number 3, 0.50 moles of carbon, and next one, 3.20 moles of copper. So again, these come from page 133 at the bottom. We've got to create a conversion factor here. So 0.5 moles of carbon. We want the unit mole to cancel out. 1 mole goes on the bottom. On top, we're going to put our mass number. Okay, that's our molar mass. So carbon's mass number is 12.01. Okay, 0.5 times 12.01. If we round that off to the nearest tenth, it's going to be 6.0 grams of carbon. And just for clarity's sake, let's put grams of carbon up here in our conversion factor. Okay, 3.20 moles of copper. We want 1 mole to go on the bottom, and the mass number for copper is 63.55, and that's grams of copper. Whoop. Okay, 63.55 grams of copper. Now we multiply 3.20 by our numerator here, 63.55. That leaves us with an answer 203 point, we'll round it off, 4, and that's grams of copper. So on page 134, you're going to do problems 1 through 9, and on page 135, you're going to do problems 1 through 3. On page 134, problems 5 through 9, you're going to have to show your work. So go ahead and do these problems on paper. It's going to be practice from what you've gone over today. And if you need to see more example problems, there are several in the book. Specifically, there's one on page 133 that you might find helpful.